Hello guys, guy123456789 here, and today I'm doing a tutorial on Bresenham's line drawing algorithm. And so to begin, I'm going to start by defining a line in terms of 2 points, which is typically what you want to do when you're drawing lines. So, well, in a computer sense, we're going to use the point-point equation of a line. Basically, you can write the equation of a line given 2 points. So what we did here was simply define the slope in terms of the initial points and the end points, rise over run, and then the free variables x and y in their initial points. So here we did an example, and we have the initial point 2 and 3 and the end point 6 and 11. And here on the screen you can see that I've plotted it, and here I've pointed out the initial and end points. So yeah, now what we're going to do is we're going to try to plot integer values that approximate this line, or approximate the slope of this line. So basically what we're going to do is we're going to do a bunch of checks against our slope value. So we're going to use this general equation here, and we're going to solve for slope. So the slope is this part here, so we simply divide by this. Okay. So now we have the free variables and their initial coordinates in terms of slope and vice versa. So now what we're going to do is we're going to increment the x-coordinate, increment meaning increase by 1, and we're going to check that value against the slope. If it's, and this is arbitrary to some extent, it can be greater than or less than, we're going to check to see if the value that we obtain when we increment x is less than the slope, then we're going to increment y as well. So if by incrementing x, we end up with a value for the slope that is less than the defined value over here by the initial and endpoints, we're going to increment y as well. So let's begin. We're going to start by solving this equation for the slope. Okay, so let's come up with a value for this. I believe that this is 0.5. So 0.5, yeah. 0.5 is equal to this, so 0.5. So we're going to check to see if this value is less than 0.5. Ignore the pretty colors. So yeah. So we're going to start with our initial coordinate for y. That's going to be 2, and x is going to be 3. So now that's 0 over 0. That's rather undefined, but in this case that is 0.5 actually. We're going to increment x. So x is now going to become 4. 0 divided by 1 is 0, and that is less than 0.5. So we're going to increment y as well, so it's going to be 3. So now we have a value greater than 0.5. So we're going to plot that point. So let me just copy that, and we'll paste that point right here. So it's going to be 4, 3. So now we have this point right here, and it's sort of off the line, but let's see if that corrects itself next time around. So now we're going to increment x again. Oh, whoops, that should be 5. And we see that that is equal to 0.5, which is not less than, or which is not less than 0.5. So we're going to plot that point as well. So it's going to be 5, 3. And now we see that the point is back on the line. So now we're going to do the same process. We're going to increase x again by 1, increment. And we see that we get a value 0.3333, and that is less than 0.5. And so we increment y as well. We get 4, and now we get a value greater than 0.5. And so we're going to increment both x and y. So it's going to be 4, 6. There we go. And now we're going to do the same process again. That's sort of what an algorithm does. We're going to increment x. 7, we get 0.5. So now we plot that point. Alright, and so we see that this is in fact plotting points that are on the line. Let me quickly fill this out. Or we can see that this is approximating the slope of the line. So it's going to be 6. Whoops, that's 5. That's 9. And the last point is going to be 6, 10. All right, so we see that this is approximating the line. And if we were to sort of fill in these boxes here, we'd end up with the pixels on a screen. So I've generated a function that represents what we've plotted. So I'm going to turn off this line. And we see now that we've created a sort of stepping function following the line. So basically, let me finish this up with a summary of what exactly the algorithm is again. So we're going to delete all this. The algorithm is based off the point-point equation of a line. So basically what you would input to your I guess you could call it a GPU to some extent. What you would input is going to be the initial and endpoints of your line. So it would be x2 minus x1 over x, or y, what am I doing? y2 minus y1 over x2 minus x1. Okay, that's our slope. That's equal to our free variable y minus y1 over x minus x1. And so what the line drawing algorithm does is it increments x, and it checks to see whether you have gone below the value that you input, which is the slope. And basically, this only works for slopes that are equal or less than or equal to 1. So if your slope is greater than or equal to 1, you have to increment y and check to see that it is less than the slope. So basically you do the, is it inverse or converse statement? I think it's inverse statement. You do the opposite sort of. And by that you can plot a line of slope greater than 1. And also, I'm talking about slopes that are positive. Negative slopes work too. So you can plot for slopes between -1 and 1 using incrementing x first and checking to see that it is greater than the slope. And you can plot slopes that are greater than or equal to 1 and less than or equal to -1 by incrementing y and checking to see that it is less than the slope. Alright, thanks guys for watching and listening to my terrible ramblings.